Hi there, Valerie and Kyle here on EchoSlam. Okay, let's try a quick word association. You ready? Antarctica. What jumps into your mind? I mean, for me, and probably for you too, it's ice, isn't it? Just endless ice, massive glaciers, biting cold, snow. Basically this huge, uninhabitable, frozen desert.
Yeah, that's the classic image. Stark, frozen, empty.
Exactly. But here's a twist. What if I told you that deep under all that ice, there's a lake? And not just, a water lake, a lake of actual molten lava, roaring, bubbling away.
It does sound like something straight out of science fiction, doesn't it? A real paradox.
Totally. It sounds completely wild, but it's real. And the confirmation is actually quite recent.
It really is a geological marvel. So today, we're doing a deep dive into this. We're asking, how is this even possible? Fire under ice in the coldest place on Earth. We'll look at where it is exactly, how scientists finally pinned it down, and what it tells us about, the planet's hidden workings.
Ooh, nice.
And we'll even take a little tour of the Earth's other persistent lava lakes. It's a pretty exclusive club.
An exclusive club. I like that. Okay, so let's start with this eighth wonder, as you called it, Mount Michael's lava lake. Now, for us, hearing this is probably a shock, like a real bolt from the blue. But, for the researchers involved, not entirely unexpected, which is fascinating in itself.
That's right. Scientists from University College London and the British Antarctic Survey, they suspected this for more than 30 years.
30 years, just based on a hunch. That's incredible scientific dedication.
It really is. See, back in the 1990s, they were noticing what they call them weird thermal anomalies, basically unusual heat signatures coming from the volcano's crater. They knew something was up. But the technology back then, it just wasn't there yet.
Ah, right, like the satellite pictures weren't clear enough.
Exactly. The resolution was too low. They could see heat, but couldn't confirm a persistent liquid lake. It was this tantalizing clue, almost frustrating, I imagine.
Okay, so fast forward, things change. July 2019, what happened?
Technology catches up, big time. We get these much more powerful satellites, Landsat, Sentinel-2, Aster.
Ah, the big guns.
Right. These aren't just taking photos. They have sophisticated thermal imaging radar. They can essentially see heat and subtle ground changes, even through clouds and ice.
Okay, so that's the game changer.
Absolutely. They looked at the new high-res data, and boom, there it was. Confirmation after 3 decades of suspecting.
Wow. That must have been a huge aha moment for them. Decades of work paying off.
Definitely. And the location itself, it just adds to the whole story. This lake is inside Mount Michael,
which is an active volcano,
on this tiny, incredibly remote place called Saunders Island, part of the South Sandwich Islands chain, way out in the South Atlantic.
Sounds properly isolated, like end of the earth stuff.
Pretty much. Very far from, anything really. Shipping lanes, people.
And the lake itself. Is it huge?
It's impressive. Not the absolute biggest, but significant. The diameter varies, maybe 300 to 700 feet across. Think like a couple of football fields.
Okay, decent size. And hot, I assume.
Oh, incredibly hot. Reaching temperatures up to 2,330 degrees Fahrenheit.
Whoa. Wait, 2,330 F. What does that even mean?
Well, put it this way. That's hot enough to melt steel. Easily.
Right, so rock staying liquid against Antarctic cold. That's just mind-bending.
It really is.
Yeah.
Which brings us to the question. Why did it take so long to find something this dramatic?
Yeah, if it's that hot and that big.
The main reason, extreme remoteness. Getting to Saunders Island is difficult. A long, tough, potentially dangerous boat journey through icy waters.
Right, not exactly a weekend trip.
Not at all. You could maybe charter a specialized cruise, but you're talking serious money, like over $10,000 per person.
Okay, so that explains why not many people have popped over for a look.
Exactly. Very few researchers had ever been, and those who did, they mostly just saw the base of the volcano. No one had actually managed to get to the summit to look into the crater. Too difficult, too dangerous.
So the satellites were really the only way to confirm it without someone physically standing there.
Precisely. They provided the crucial definitive evidence that decades of theory needed.
Okay, so we know it exists, we know where it is. But the really big question, I guess, is why? Why does this lava stay liquid? Because usually lava flows, it cools down pretty fast, right? Days, maybe weeks, then it's solid rock.
That's the standard behavior, yes.
Yeah.
Most of the world's 1,500 or so active volcanoes work like that. But Mount Michael and only 7 others like it have these persistent lava lakes. They just stay molten.
So what's their secret? What makes them different?
That was a big puzzle for geologists for a long time. Why just these few? Out of so many. The answer, it turns out, lies inside the volcano itself. It's about constant, vigorous volcanic gas activity.
Gas, like bubbling up from below.
Exactly. The steady stream of gases, think sulfur dioxide, steam, carbon dioxide, continuously rising from the magma chamber.
Okay, so how does that keep the lava liquid?
It acts like a constant heat source, like constantly stoking a furnace. These rising gases keep the temperature inside the crater incredibly high, preventing the surface lava from cooling down and solidifying.
I see. So it's not just magma coming up, it's the gases with it that maintain the heat. It's like a self-sustaining system.
Precisely. It's a dynamic balance. The volcano is essentially feeding its own fire, keeping that lake churning.
And figuring that out, that must be important for understanding volcanoes generally.
Hugely important. It changes how we view volcanic persistence. It's not just about how much magma is supplied, but about this complex interplay of gas pressure and release. It helps scientists get a better handle on potential volcanic hazards, even in remote places like Saunders Island. And interestingly, studying Mount Michael actually helped refine techniques for monitoring volcanoes using satellites.
Oh, really? How so?
Well, tackling the challenge of confirming this lake pushed the development of specific ways to analyze thermal data and other signals from space, which we can now apply globally. It's a big step for monitoring and safety.
That's amazing. So what's next for Mount Michael? Are scientists planning to fly a drone over it or something?
That's definitely the dream. Getting closer looks, maybe with planes or specialized drones,
Yeah.
to gather more detailed data.
But I guess that's easier said than done in Antarctica.
Oh, extremely difficult.
Yeah.
You're dealing with brutal weather, the remote location, and an active volcano. Organizing such a mission takes years of planning, massive resources. It's a huge challenge.
Right. Okay, so Mount Michael is number 8. You mentioned an exclusive club. Let's talk about the other 7. Where else does this happen?
All right, let's take a quick tour. Probably the most famous and the largest is Mount Nyiragongo in the Democratic Republic of Congo.
Nyiragongo, I think I've heard of that one. It's quite active, isn't it?
Very. It's erupted 34 times since 1882, sometimes with the lava lake phase lasting for years. The lake itself can be over 800 feet wide and incredibly deep, maybe up to 2,000 feet.
Wow, that's enormous.
It is, but it's also extremely dangerous. Not just the lava, but it releases toxic carbon dioxide gas from the ground around it.
CO2
Yeah.
seeping out.
Yes, silently. If the wind doesn't blow it away, it can accumulate and be lethal. And tragically, in 1977, the crater walls actually fractured.
Oh no, what happened?
The entire lake just drained. In about an hour, lava flowed down the slopes at something like 60 miles per hour.
60 miles per hour?
Unbelievable speed.
Right.
Overwhelmed nearby villages, caused terrible loss of life. A real catastrophe.
That's terrifying. Okay, so Nyiragongo is the biggest and perhaps the most dangerous. What about the other Antarctic one?
Yes, Mount Erebus, also in Antarctica, and it's actually the continent's most active volcano.
So there are 2 down there.
That's right. Erebus was also a puzzle when first found. Again, that contrast active lava in the coldest place on Earth.
Does it behave like Mount Michael?
It has its own quirks. Erebus is famous for throwing lava bombs, basically. Blobs of molten rock flying out of the crater.
That's lava. Okay.
Yeah. And scientists have been watching it closely since the 70s with cameras, seismometers. They describe it like a sleeping dragon. The lava churns, kind of huffs. Yeah, gas plumes rise and fall rhythmically every 5 to 18 minutes or so. And the lake surface actually pulses up and down with it by about 6 to 8 feet each time.
That's incredible. Like it's breathing.
It really is. And you see the surface cool, crack, and then new boiling lava wells up through the cracks. It's constantly renewing itself.
Fascinating. Okay, we're next on our tour.
Let's go to Hawaii. Kilauea, one of those active volcanoes anywhere.
Right, Kilauea is famous. Did it have a persistent lake too?
It actually used to have 2. One in the main summit crater, Halmomo, and another in a cone vent called Poosh.
Used to. What happened?
Well, back in 2018, there was some major eruptive activity on its East Rift zone, and it basically drained both lakes. Change of the volcano's internal plumbing quite dramatic.
Oh, so they're gone now.
For now, yes.
Huh.
But the scientists at the Hawaiian Volcano Observatory are pretty hopeful that at least the main summit lake might reappear someday. They're watching closely.
Okay, fingers crossed for that one. What else is in the club?
Head over to Ethiopia to the Afar Depression. You'll find Urta Ale.
Urta Ali.
This one's interesting because the number of lakes can change. There's usually one that's persistent, but sometimes others pop up temporarily in the crater.
And what's it known for?
Visually, it's stunning. It often has these overflows where lava spills over the crater rim and flows down the slopes in these bright orange streams, Really spectacular, especially at night.
Wow, like fiery rivers.
Mhm.
Okay, that's 5, plus Mount Michael makes 6. What are the last 3?
Okay, the final 3 are Ambrim Volcano in Vanuatu,
Vanuatu, okay.
which is unusual because it sometimes hosts 2 persistent lakes simultaneously within its caldera. Then there's its neighbor, also in Vanuatu, Mount Yasur.
Another one in Vanuatu.
Yep. Yasur is known for being relatively accessible. You can actually get quite close safely and see the molten lava and its frequent smaller explosions.
Really? You can get close? That must be intense.
It is. And finally, there's Masaya in Nicaragua. Locals apparently call it the mouth of hell,
Catchy name.
isn't it? And it's another one where you can, relatively speaking, get quite close to the crater rim and really feel the heat and see the churning lava below. A very direct experience.
So Ambrim, Yasur, and Messiah. Got it. What an incredible list.
It really is a select group of geological wonders.
Absolutely. So we started this deep dive thinking about Antarctica as just ice. Pure, cold, solid ice. And we end up finding these persistent lakes of fire hidden away, completely defying that image. It really does show how much we're still learning about our own planet, doesn't it?
It really does. And what's so exciting is how technology, like those satellites we talked about, keeps peeling back layers, revealing things we never knew were there. These lava lakes, these pockets of intense heat, they're not just oddities. They're giving us real clues about the massive forces deep inside the Earth, the things that shape continents and drive geology on a global scale.
Right. Understanding these extreme isolated spots helps us understand the whole system better.
Exactly. It makes you wonder, doesn't it? What else is out there? What other incredible phenomena are just waiting to be found, maybe in places we least expect, or hidden right under our noses?
That is a great thought to end on. What other impossible things might be out there, challenging everything we think we know? Something for all of you to think about. Thanks for joining us on this deep dive. We'll catch you next time.